You know me as mathematics. For thousands of years, I've been your language for the universe. But I wasn't always this rigorous, logical thing you see today. My story, my real foundation, was actually forged way back in ancient Alexandria, around 300 BCE. It was all thanks to a quiet man named Euclid, who gave me a backbone of pure, unshakable logic.
See, in my youth, I was basically a collection of clever tricks. The Babylonians used me to predict eclipses, the Egyptians to build pyramids, and don't get me wrong, those were incredible feats, but they were results without roots. I was just a practical tool, this big grab bag of methods that worked, but nobody could really say for certain why they worked.
And that was my crisis. My arguments often boiled down to intuition, to these unstated assumptions, these vague appeals to what just looked obvious. I was useful, for sure, but I wasn't sound. I didn't have a foundation you could absolutely trust. If I was going to be the language of truth, I needed to be built on something a lot more solid than sand.
And then he came along, my architect, Euclid. Now, his genius wasn't really in discovering a bunch of brand new theorems. It was something way more profound. It was organization. He looked at all these scattered scrolls of Greek thought, the work of guys like Pythagoras and Eudoxus, and he imagined one single, perfect structure. His project was called The Elements, and let me tell you, it was maybe the most ambitious intellectual project in human history. The plan was simple: compile all of known geometry into one single work, where every single theorem was proven step by logical step from just a handful of first principles. No more guesswork, no more, that looks about right, only pure, verifiable logic. To pull this off, Euclid gave me this revolutionary idea, something that would become my bedrock for the next 2,000 years, the axiomatic method. It sounds kind of obvious now, but back then, it changed everything. The idea is actually pretty simple, but it's so powerful. You just state all of your starting assumptions clearly and explicitly. Hide nothing. Put them all out there. Then, using only the rules of logic, you derive everything else from that small set of truths. Every proof would be like a chain, with every link of logic leading all the way back to an undeniable starting point. So these were the rules of the game, my common notions. And yeah, they seem almost laughably obvious, don't they? Things equal to the same thing are equal. The whole is greater than the part. Well, duh, but that was Euclid's genius. He made every single assumption explicit. This was the grammar all my arguments had to follow. And these were my geometric building blocks, the postulates. Just simple ideas, like a straight line can be drawn between any two points. They basically formalized what you can do with a straight edge and a compass. Simple enough, but there was a fifth postulate. And that one was going to cause some trouble for a very long time.
You see, that fifth postulate, the one about parallel lines, it just felt different. It was clunky, it was way more complex, and it just wasn't as self-evident as the others. Mathematicians immediately thought, that's not a basic assumption, we can probably prove that from the other four. Well, they tried, and failed for the next 2,000 years. And in the process, they accidentally discovered whole new geometries.
Okay, so with these rules in hand, Euclid started to build, and I mean he really built me, proposition by proposition, with the kind of precision you'd expect from a master mason laying bricks.
He kicked things off with Proposition 1, how to construct an equilateral triangle. Every single step is justified directly by a postulate. There are no leaps of faith. The result isn't just a drawing, it's a logical certainty, a timeless truth that anyone can verify just by following the steps.
And this is how the whole thing grew. Proposition 2 relied on Proposition 1. Proposition 5, the one they called the Bridge of Asses because it stumped so many students, built on what came before. By the time he reached Proposition 47, he'd built a logical ladder tall enough to prove the Pythagorean theorem with unshakable certainty.
Now, Euclid's method wasn't just for lines and circles. He applied that same hardcore rigor to the very nature of numbers themselves. And he asked one of the deepest questions you can imagine. Are prime numbers finite, or do they just go on forever? To solve it, he used this elegant technique called proof by contradiction. He started by assuming the opposite. He said, okay, let's just say there is a finite list of all the prime numbers. Then, he cleverly constructed a new number designed to break that very assumption, trapping it in this perfect logical paradox. The only possible way out of the contradiction was that the original assumption had to be false. The list of primes must be infinite. QED, quod erat demonstrandum, what was to be shown. With just a few lines of pure logic, Euclid had managed to grasp infinity itself.
After 13 books, 13! Covering geometry, number theory, and irrational numbers, Euclid's massive work was ready for its climax. He set out to prove something spectacular, a complete catalog of the most perfect, symmetrical 3D shapes possible in the universe.
And he proved, with that same relentless logic, that there can only be 5, not 4, not 6, exactly 5 of these regular convex solids, the Platonic solids. The four-sided tetrahedron, the familiar cube, the octahedron, decahedron, and finally the icosahedron, with its 20 triangular faces. This was the grand finale, proving that only these 5 perfect solids could exist, gave the elements this beautiful philosophical closure. These weren't just shapes, they were the absolute limits of symmetry.
And in that moment, my transformation was complete. The sand had been replaced with granite. I was a coherent, verifiable, and cumulative science, all built on a foundation of axioms and logic that would stand for millennia.
So what was the point of all this? Well, there's a story that when a student asked Euclid what the practical benefit of geometry was, Euclid just turned to his assistant and said, "Give him a coin, since he must profit from what he learns." You see, for Euclid, the goal wasn't just about utility, it was about understanding. It was the beauty of pure reason itself.
The Elements became the second most printed book in the Western world, right after the Bible. It literally became the template for rigorous thought. Philosophers, lawyers, scientists, even presidents like Abraham Lincoln, they all studied Euclid to learn how to reason, how to build an argument from the ground up.
Euclid gave me the structure I have today, a language of proof and certainty. But that grand, logical building, the one that would eventually describe everything from planetary orbits to quantum mechanics, it was all built on the most basic of human impulses, to see the world, to measure it, and to ask that one simple, powerful question, why?